In this video, we're going to talk about how to create some simple functions of your own. So these are user-created functions that you get to create based on what you think needs to happen in a function. So what exactly is a function in R? So a function is a sequence of commands executed based on certain arguments supplied to the function. So in R, a function is going to be defined using the general format provided below. So I have my function, this is the name of the function. I have the assignment operator here. I have the word function to let the assignment operator know that I'm creating a function. And I'm going to specify a certain argument. So in this case, I've called them arg1, arg2, and arg3. You would name them whatever you want. I have an open curly brace and a closed curly brace, so I know where the function begins and ends. And then inside the function, I have some code to execute. So this code would not run. This is pseudocode. This is just to give you an idea of what functions look like in R, and we'll do some examples. And once a code is defined, then to call it, we just type something like the following in the R console. So we type the name of the function, and then we give it the arguments of the function, which I've called x1, x2, and x3 in this particular example. Depending on the kind of function you create, your function may or may not return something that you can use later. So sometimes you have like a plot function that you create, in which case it doesn't return anything but a plot. Other times it can return a numerical value, a list of values, all kinds of things like that. So this isn't showing up very well for some reason in here. But let's consider an example where we wanted to return the sample standard deviation of a vector x. So we're going to assume it's a numeric vector. We're actually not going to do any argument checking. So you may recall that the standard deviation of a vector x is the sum of 1 divided by the number of observations n minus 1 multiplied by the sum of the square deviation between each value in x and the sample mean x bar. So I haven't defined all this notation here. If you've taken a statistics course, these are all hopefully symbols that you recognize. And so we're going to create a function stdev, which computes the sample standard deviation of a vector x. And so this is probably going to be complex for you if you're only beginning R. I'm just going to kind of walk you through what we're doing here. So what we're going to do here is we're going to take the vector x, we subtract off the mean of x. So mean of x computes the sample mean, which is x bar. We subtract that from each one of the values in the vector x. We square each of those deviation by taking x minus the mean of x in parentheses and squaring it. And then we're going to sum all of those square deviations. So that's what this part represents right here. Okay. Then we're going to divide that by 1 over n minus 1. Or in other words, we're going to divide it by the length of x, the number of observations, minus 1. And then we're going to take the square root of the whole thing, and I'm going to store that I'm going to assign that value the name s. And then if I print s to screen by just returning s there, then it's going to return the sample standard deviation of the function. So this is the function that we have created here. And what I'm going to do is I want to test the function that we've built against the SD function built into R. So I'm going to generate some data, which I'm calling z here. It's just 20 values from a standard normal. And if I do SD of z, the standard deviation of z, I get 1.2. And if I do stdev of z, I get 1.2. So it does appear to return the same value. So that's a good thing. I will say though, you have to be careful because even though our function returns the same values as the SD function, we didn't do any kind of argument checking to make sure that someone didn't put in some weird value. The SD function is almost certainly optimized to be faster than what we've written. So if you can, just use the built-in functions. This is merely an example to illustrate how you would create a function in R. So here is an example where you get to try to make a function of your own. So let's create a function that returns the density of a normal random variable with mean mu and standard deviation sigma for a vector x. So recall that the density function of a normal random variable is given by this equation right here. You may not recall that if you haven't had a statistics course recently, and that's okay. But it's going to be 1 over sigma times the square root of 2 pi times the exponential function of negative 1 over 2 sigma squared times x minus mu squared. So this is what we want to compute. This is kind of complicated. And the arguments of our function are going to be x, mu, the mean of our normal distribution, and sigma, which is the standard deviation of the normal distribution. So let's go over to RStudio and see how we would actually do that. So you can see I've already pre-programmed this function up for simplicity. So I've called my function dense underscore norm, and it is a function of x, mu, and sigma. I have my open curly brace and my closed curly brace here. And it's kind of hard to see based on what we're doing here. So let's see if we can move that so you can kind of see both things at the same time. So at the start of our function here, we have 1 over sigma times the square root of 2 pi. So I did that part by taking 1 divided by sigma divided by the square root of 2 times pi. And if you're familiar with the order of operations, this is going to be 1. This is going to give you exactly what we want right here. And we're going to multiply that by the exponential function of negative 1 over 2 sigma squared times x minus mu squared. So you can see in this exponential function right here, x, I have negative 1 divided by 2 divided by sigma squared. So that's this part right here, times x minus mu quantity squared. And since we're just computing that and printing it on the same line, the dense underscore norm function will return the density values for a normal distribution with a mean of mu, a standard deviation of sigma, and values given in the vector x. In order to test my function, I'm going to generate 20 values from a normal distribution with a mean of 10 and a standard deviation of 3. And so now it's generated. You can see the values right here if you want. And then in order to compare the function we've built, we can compare it with the built-in function dnorm, which is built into R and computes the density of a normal distribution with some mean and some standard deviation. So this is the built-in results right here. And if we compare that to the results of our function, it looks like to me like everything is matching up perfectly, which is a good sign, indicating that we have in fact correctly coded what we wanted to. So just as we close this video here, I wanted to show you some examples of returning a function with a list of results. So sometimes when you create a function, you need to return more than one value or more than one piece of information. You can do that using lists. And we haven't really talked about lists, so I'm not going to go into a lot of detail about them, but I'll show you some basic usage of accessing information in a list and returning information in a list. So let's say we want to create a function that returns the mean and standard deviation of a vector x. So the sole argument of the function is going to be x, a vector of numeric values. I'm going to call this function ms for mean and sample standard deviation. So ms is a function of x, and first I'm going to compute the sample mean of x and store it in a variable called m. I'm going to compute the sample standard deviation of x and store it in a variable called s. And then I'm going to return a list with values m and s. You might wonder why I'm doing m equals m and s equals s. This is sort of like how I specified a data frame and I specified the column name for each column of the data frame. It's doing the same thing here. So I want to return a list and the first element of the object is named m. I'm just going to give it the value of m. And the second element has the name s with the values in s. And so that's what our function is going to return. And if we run ms of z, it's going to give us the sample mean and the sample standard deviation, where this is based on the z that I generated up above in this file. If I wanted to access, well, first of all, I can store the information ms returned by ms of z. I can assign it a name ms underscore z. And if I want to access the m element of ms underscore z, I can use the $ symbol, just like I did with a vector. And that's going to return the first element, 0.13, which is the sample mean of the data. Alternatively, I can use double square brackets, sort of like what we did with a vector with a single square bracket. If I want the first element of the list ms underscore z, I can use double square bracket of 1, and it gives me the same value, 0.137, that I have for the sample mean here. If I wanted to access the second element, I could use $s, where s is the name of that second element that we specified right here. Or, since I know it's the second element, I can use double square brackets to get the sample standard deviation, which in this particular file, based on what the data I previously generated, is 1.2.